So fly and fly.
Welcome to the Hollow Earth Hypothesis, Part 4, Core Physics, the Evidence. We're going to talk this section about Earth's magnetosphere. What causes it? What changes has it been going through? What new measurements have we made about it? And how is it really so unique in our solar system and maybe even in the universe? The magnetosphere is kind of a protective magnetic envelope that surrounds the Earth and protects us from high-speed, high-charged particles that approach our planet. It protects us against radiation from the sun and from other sources. You can see it depicted here in this graphic. So let's get into it. We have a lot of information to cover. When we talk about the quest to discover Earth's planetary core physics, this is the big question. We used to think that we lived on this molten ball traveling through space, and somehow we existed on these cool tectonic plates on the surface like cornflakes floating in a bowl of milk. Believe it or not, this is basically how all geology textbooks depicted our planet exists in space. Now we're getting more evidence. Now we're beginning to see from space and also from Earth measurements a little different story. So what we're going to go into now is some official and very leading edge planetary core physics on how the planet is structured, at least as much as we know today. So when we talk about what is the core composition, this was a very, very big question. We thought that it was a molten ball of rock for a long time. But in the early 2000s and the mid-2000s, on up to 2010, we began to take spectrographic measurements of frequencies put off by the core of the Earth. And what we're going to reveal to you today is evidence that proves that that is not the case. We do not have a giant molten ball of rock as the core of the Earth. We may not even have a molten inner core inside the crust rubbing against the inside of the surface upon which we live. What we know about this, we'll start with the Carnegie Science. And this is a quote. Our findings suggest that as the core was extracted from the mantle never fully mixed. This is surprising because core formation happened in the immediate wake of large impacts from other early solar system objects that Earth experienced during its growth, similar to the giant impact event that later formed our moon. Before now, it was widely thought that these were very energetic impacts. They would have completely stirred the mantle, mixing all of its components into a uniform state. We kind of depicted it like this, that Earth may have collided with some larger body. In other words, what we tried to explain with this planetary core physics, because of evidence we've gained not only from the Earth but from other planets in our own solar system, is that two worlds merged, or they collided in space. There are two aspects that we're going to consider here. The first is that these two planets were similar in size, maybe of different makeups. One very high vibrational and one very low vibrational, one very high frequency, low frequency. They came together not as similar bodies, but as dissimilar bodies, so that they didn't destroy each other, they more merged together. The reality is that the mass that makes up our planet Earth is not very dense at all. In fact, a neutrino, which is a tiny little, very fast particle traveling through space, sort of like its own galactic wind, Neutrinos could pass through a light year of Earth and not hit anything. That's how much space there is inside the molecular mass that makes up our planet. So it would not take much to imagine a slightly different dimensional world merging with our world in this solar system. The second aspect is that perhaps one was very much smaller than the other. Maybe a quarter our size, or a third our size, or a tenth our size, but maybe very dense in mass, and so it punctured through the crust and became part of the inner core. Now, this isn't so outlandish because in our own solar system, we have a planet that matches this description right now. We didn't know this several years ago. We only knew this recently, even though we sent the probes a long time ago to the planet Uranus. We studied that planet for decades, and it takes a long time for a probe to go around a gas giant that size. But what we have discovered is that inside of Uranus is another planet. There's another planet on the inside of Uranus, orbiting or turning at a different speed. We wanted to study this because we knew that the way Uranus revolves on its axis relative to the other planets in our solar system is all wrong. Something was definitely different about this planet. And when we sent our probe and we discovered, this is what we found. It had an impact with another planet, and that planet is still on the inside of Uranus. So if it can happen to that planet, why couldn't it happen to Earth? This is just a theory that's out there. So the question we want to ask is, what if two worlds of different energies merged to occupy the same space at the same time? I call that the union of the polarity. My co-author E.J. Clark and I wrote 4 books on this called The Arc of Millions of Years. It's 2,000 pages of non-fiction work studying 44 ancient cultures and matching it up with modern physics, modern geology, and modern cosmology to explain those ancient traditions. This is what we came up with, what we call the union of the polarity. It is very carefully explained in those books, and it's fictionally explained in the Birth trilogy. So the union of the polarity would have been a rare event in the universe, to be sure. It wouldn't have been cataclysmic in the sense that both planets were destroyed. It wouldn't have knocked it out of the solar system. It would be an event of beauty and of resonance. And this is what we propose with a possibility of the hollow Earth hypothesis. So this great magnetosphere that we have is formed because we have 2 counter-rotating bodies, one on the inside and one on the outside. The outside one is a 900-mile thick crust full of iron and rock and all kinds of gases, and it's undulating. That is to say, it's stretching and squeezing because the moon is going around us and we're going around the sun and we're revolving on our axis. All of these gravitational fields have an effect on the integrity of this crust, so it is moving all the time. And as it moves, it generates a lot of heat, a lot of movement, a lot of magma moving around in it. We're talking about 900 miles of thick, dense matter. Then a gap. We don't know how big this gap is. We suspect it's somewhere around 1,000 miles. And then a very hard, solid, single metal core. I'm going to explain that to you in a minute. But the core would be rotating on its axis at a very high, a relatively high RPM. That is to say, rounds per minute or rounds per day. The crust itself takes roughly 24 hours to make its revolution. So the crust is moving slower, the core is moving faster, and that counter-rotation creates this tremendous magnetic field around the planet, which you see depicted in this graphic. When we break this apart and we try to look at it, this is what we think it looks like. This is the most common modern cosmological model of what the Earth looks like right now. We have the tropospheric surface upon which we live, the green and lush surface with water, not very thick at all. And then we have this crust I explained to you that was depicted in the bright orange body here, 900 miles thick. Then we have an unknown area. We don't really know much about it. We can't tell much about it by a frequency. We can't tell much about it by seismic information. We don't believe that it is very dense because otherwise it would be dragging the core to a stop or into the same revolutions as the crust itself. So the theory is that this area is actually open space, that it's actually air, or it's actually, hot gases. And then the bright ball in the middle. Now this is what we are beginning to know the most about. We're beginning to measure it. We measure its frequency that it puts off coming up through the crust. What we know now is the answer to this question. What is the composition of the core? This is the question we've been talking about for upwards of 8 years, and now we have some very, very good data to share with you in this section. We don't really know what the composition of this space is. Let's just not talk about that tonight. It could be molten rock. We don't think so. It could be open air. Many people and many ancient cultures believe that is the case. So we know from Arizona State University reports that they have detected continent-sized blobs of semi-liquid magma inside the crust. And the estimates are the crust is about 900 miles thick. Now, these continent-sized blobs are, as I said, semi-liquid. They're molten, but they're more like glass. Glass is a liquid, but it just moves very, very slowly. If you look at old windows, for instance, you can see that the silica in the glass is flowing from the top of the window pane to the bottom of the window pane, and it kind of makes it wavy. That's because it is flowing. It's just flowing very, very slowly, kind of like a glacier. That's what these blobs are like in the inside of the Earth. Then we have received spectrographic information. On the left side of your screen here, you will see a typical absorbance curve. This is where we have noticed that energy is being absorbed at specific wavelengths that are consistent with iron. You can see in the right side of this picture here a solid iron crystal. The small red dots that you see in here are xenon. Most of the xenon in the Earth, or of the Earth, is locked in the core, in this iron crystal matrix. We know this because we can measure this spectrographically. It's been measured in numerous occasions, numerous different labs, and these absorbance peaks are very, very sharp, very repeatable, and very identifying for iron. But it is a specific state of iron. Iron, as you know, can assume a lot of states. It can be rust, it can be ground state iron. It has 3 different oxidation states. And we know the frequencies that these different oxidation states put off, and we know the frequency that's being put off by an iron crystal. The issue is that this iron crystal has to be under a lot of pressure, and it has to be under very high temperature, about 6,000 degrees C, which is the same temperature as the surface of the sun. That's pretty hot. It's also not really duplicatable in any ordinary sense. So what they have done is they created an experiment. This is called the diamond anvil. It was created a long time ago, but now it's being applied by Carnegie Science, by Cambridge, and by other universities around the world. Typically what this is 2 large industrial-sized diamonds, very hard. And then what they do is they put an anvil in between these, a crucible of sorts. And then they push these together at very high pressure, creating or duplicating the pressure that would exist at the center of the Earth on a very small point. And then they shoot a laser through the diamond to heat the crucible up to 6,000 degrees C. And then they measure the frequency that's being put off by this iron crystal. And lo and behold, it is exactly the same as what is being put off by the core of the Earth. This is an example of the crucible that's placed in between the diamond rams that are pressed in on it. You can see it's not very large. It's got a very small area where a small amount of iron is placed, and then it's pressed into crystalline form. This is another image of the same thing. And what was formed now is not just a black ball. What is formed is a crystal form of iron. It looks something like this. This is what the Earth's core is made of. You can see, this is obviously outside the crucible, it's a close-up picture of it, but this is what the core of the Earth is made of. Now it's at about 5.3 grams per cubic centimeter. This means it's more dense than almost any matter on Earth. It's also at 6,000 degrees C. So this is way up in temperature, same temperature as the sun. And what kind of light would it put off? Just like this. This is an iron filament lamp. It puts off a frequency that has a wavelength between 446 and 520 nanometers. That's 1/1000th of a meter. So it is a light that can be used to cause photosynthesis, because photosynthesis is best at 450 nanometers, obviously very close to the middle of this frequency band that's put off by the iron. So if temperatures are suitable, that anything organic wouldn't be immediately combusted like is on our fire tonight, it would grow just like plants on Earth. What would they look like? We don't know. But if photosynthesis will be sustained, then so will also other forms of life. One of the other things that we notice about the magnetosphere is that it wobbles. For many millennia, the solid core and the massive crust of the Earth were well aligned, straight up and down. But there are unstable forces between them that must be considered. Any two bodies that are rotating together have a gyroscopic property about them. And these two bodies have different rotational speeds, which are creating this magnetosphere. Of late, the wobble in the alignment of the north magnetic pole has been rather pronounced. The north magnetic pole normally moves by a force which is called the Coriolis Effect. The Coriolis Effect is an effect whereby a mass moving in a rotating system experiences a force acting perpendicular to the direction of motion and to the axis of the rotation. You could take a bicycle wheel and you could spin it very fast, and you could try to turn that bicycle wheel flatways, and it will resist that movement. That is the Coriolis effect. It is a force perpendicular to that rotational force. We're seeing this not in one, but in two bodies. And now those two forces are beginning to work against one another, and so they're beginning to wobble. Now, what does this mean for us? In recent rapid movement, the North Pole could be exhibiting the behavior of the beginning of a pole reversal. The sun goes through this about 11 years. Every 11 years, the north and south poles of the sun switch. Is it cataclysmic for the sun? No, not really. Would it be cataclysmic for the Earth? We believe so on several different levels. First of all of the animals that use magnetic fields of the Earth for navigation would have to recalibrate, if that could be done. The way we navigate our own aircraft, our own map systems, our own systems of knowing which way is north, which way is south, east and west on our planet is changing. Of late, we've had to sandblast the numbers off of runways and change them because the north magnetic pole is changing the compasses of the aircraft. So we could be getting ready for a pole shift. We don't really know how fast these pole shifts occur or how frequently they occur. We know that Earth, somewhere around 100 to 120,000 years ago, the North Pole was the South Pole, and vice versa. We don't know if this takes 1 year, 7 years, or 700 years to occur, but we know that it's fairly quick because we have a record in the igneous rock. Igneous rock is formed when molten rock freezes. When it freezes, it assumes the magnetic alignment of the Earth at that time. We have a vignette of these alignments in igneous rock around the planet, so we know that the poles were shifted at one time or another. All this is evidence, and we cover this in the fictional story Birth, Two Earths, One Race for Time. It is now a trilogy. It's 1,100 pages, and it is a story that walks you through this cataclysmic joining and re-separating of the two worlds. We don't know if the planets are getting ready to separate or not. We don't know if they're getting ready to change poles. But if you want to read a great story about it, you can find it on Amazon. Birthtrilogy.com will also lead you to the same place. So, this is the story of the construction of the Earth. We know that this magnetosphere exists. We know what causes it. We have observed it in other planets. Mars, for instance, doesn't have a magnetosphere. It could be because Mars does not have a core. It could be because Mars' core is rotating at the same speed as Mars's crust. If that was the case, no magnetic field would be generated. Without protection, the surface of Mars is subjected to the shortwave or high-frequency radiation that comes from the sun, effectively sterilizing its surface. The same exact thing would happen to Earth if our magnetosphere were to disappear. Our atmosphere over the last few decades has been shrinking, especially during solar cycle 24. Why? Earth itself makes its own atmosphere, of course. We have respiration that goes on the planet, we have combustion that goes on the planet, and various gases change in slightly between their partial pressures on our planet, but the atmosphere is also added to by solar ejections, coronal mass ejections, and also the solar wind and particles that come from the sun to the Earth excite and then join our upper ionosphere and make our atmosphere larger. Because the sun has been so quiet, we haven't been getting that feed of particles and material from the sun like we normally do. So our atmosphere has begun to shrink. This has had some effects which we already are seeing the results of. Number one, our satellites in orbit are lasting longer, up to 10 years longer. Why? Because they're no longer dragging against the upper atmosphere, slowing down, having their orbits decay and falling to Earth. Those satellites haven't had to be replaced because they're not running into the atmosphere. They're still orbiting in free space without running into anything. The second effect is we're losing our insulative blanket around the planet. That means that the Earth itself can radiate more of its energy back out into space. We call this albedo. That's the amount of energy we receive from the sun that is reflected back out into space. Without our insulative blanket, Earth is going to begin losing its energy to space, which means Earth is going to begin cooling, not warming, cooling. We could be headed for an ice age if the sun doesn't pick up its activity in the next 5 to 10 years. By the way, ice ages do not approach slowly. They approach quickly. 1 or 2 winters is all it takes for an ice age to get started. All it takes is for snow to fall on the snow from the previous year. When that happens, infrared radiation that would normally be absorbed into the ground, warming the ground up, is reflected back out into space. Without the ground warming up, the Earth will rapidly cool. If this occurs, we could be looking at the farm belt in North America moving south by as much as 300 miles. 300 miles to the south. These are effects that we know about. Mathematically, they are not only probable, they are very possible. And I think that these are things we need to be aware of. This is why I think people are becoming more sensitive to the idea of hollow earth theory. It is not so much a journey to the center of the Earth as it is understanding the cosmology and the planetary core geology of what makes up planet Earth. I'm Brooks Agnew. This is the Potential of All Potentialities channel on Sci-Spy TV. Thank you for joining us.